All right, so this is simulation using random numbers, okay? And so what if each multiple choice question had 5 answer choices instead of 4? How does this change the probability of guessing correct answers? I would say it makes it worse. Instead of creating a new spinner for this simulation, you can design and carry out a simulation for the 5-question test guessing experiment using a random number table. A random number table is a table that displays, get this, random digits. Over here it says the digits of a random number table are often displayed with a space after every 5 digits so that the digits are easier to read. Some random number tables also place a space after every 5 lines for the same reason. Choose any line in the random number table and let the numbers 0 through 19 represent a correct guess, and 20 through 99 represent an incorrect guess, and incorrect guesses, since each answer choice in a question has a 20% probability of being selected. Okay, and so when I look at this, they give an example here. This line of a random number table shows one trial of the simulation. The numbers 12, 64, 56, 20, and 00 are chosen. This corresponds to correct, incorrect, 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 and correct. So in this first trial, the correct answer had guessed 2 times. Okay? Or the correct answer was guessed 2 times. So with the idea that from 0 to 19, it would be a correct answer. And from 20 to 99, it would be an incorrect answer. Okay? So use the random number table at the end of the lesson to select random 2-digit numbers as a simulation. Conduct one trial of the experiment. List and interpret the results of your first trial. So I'm just going to start everything from line 1. And so if I do that, my first 5, 65, 28, 59, 71, 1, 2, 3, 4, and 98. So no, 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 no. And let's see here. My first number, 65, 28, 59, 71, and 98. For those 5, I would have 0 correct answers. And so now we're going to continue doing this, and we're going to kind of hold this experiment again using the random number table to determine how many correct we would probably get if we guessed on a 5-answer multiple choice test. Okay. All right, so now we have to conduct a total of 25 trials, and then we need to record our results. Notice what it says here. You do not have to start your first trial at the beginning of a line of the random number table. You can randomly start at any number on the line. That makes sense because they're random numbers. So if we randomly start, it's okay. To make it easier, I'm going to do these first ones, though, and I'm going to have them correspond here because we'll get through a lot of them, okay? I think I will count my trial 1. And so my trial 1, I had 0 correct answers, okay? Then in line 2, I'll do my next one. So I have 17, 26, 45, 73, and 27. Okay? So correct, incorrect, 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 incorrect. So I would have gotten 1 right for my second trial. Okay? Then third trial, I am going to have 95, incorrect, 63, incorrect, 99, incorrect, 97, incorrect, 54, incorrect, and so I would have had 0 correct that time. Okay. You could do this separately and see how your results compare to mine, and that would be totally and fine. We're just conducting simulations to try to learn about the theoretical probability of a situation. Incorrect, 55 incorrect, 57 incorrect, 64 incorrect, 4 is correct. So there'd be 1 right there. For line 5, 78 wrong, 13 correct, 79 wrong, 87 wrong, 68 wrong. There'd be 1 correct for line 5. Line 6, 62 wrong, 49 wrong, 9 right, 92 right, 15 right. I'm sorry, 92 wrong, 15 is correct, and 9 is correct. So that would have been 2 right for line 6. Line 7, 24, no. 21, no. 66, no. 34, no. 44, no. Would have been 0 right. 8, 19 is correct. 97 wrong. 59, no. 54, no. 28, no. So there would have been 1 right in line in trial 8 for me. Trial 9, 59, no. 13, yes. 83 no, 95 no, 42 no, would have been 1 correct in line 9. In line 10, we would have 29 no, 47 no, 85 no, 96 no, 52 no, 0 correct. 11, 96 no, 15 yes, 59 no, 50 no, 9 yes. That would have been 2 right there. Line 12, 29 no, 62 no, 16 yes, 65 no, 83 no. There would have been 1 correct there. 13, 12 yes, 63 no, 97 no, 52 no, 91 no. There would have been 1 correct there. Okay. This is looking fairly similar to last time, but we'll compare our results for a 5-question test to a 4-question test when we're done with this. We still have some more trials to complete. Okay. So trial 14. 14 yes, 54 no, 43 no, 71 no, 34 no, 1 correct. 83 no, 40 no, 38 no, 88 no, 27 no, 0 correct. 16, 67 no, 64 no, 20 no. It was 0 to 19 and then 20 to 99. 52 no, 4 yes, 1 correct. 64 no, 4 yes, 19 yes, 90 no, 11 yes. That would have been 3 correct. 3 out of 5, 60%. All right, 18. 17 yes, 4 yes, 89 no, 45 no, 23 no, would have been 2 correct. 19, 93 no, 3 yes, 98 no, 94 no, 16 yes, 2 correct. 20, 82 no, 24 no, 43 no, 43 no, 92 no, 0 correct. 5 more trials left, and then I'm going to kind of go back up to the top, I guess, and I'll do the next ones there. So 12 yes, 13 yes, 85 no, 30 no, 10 yes. That would have been 3 correct. Let me move that over. There you go. 38 no, 22 no, 42 no, 93 no, 1 yes, 1 correct. 31 no, 19 yes, 99 no, 25 no, 58 no, 1 correct. Then 24, 86 no, 21 no, 41 no, 18 yes, 8 yes, would have been 2 correct. And then last but not least, 4 yes, 68 no, 98 no, 71 no, 30 no, 1 correct. Okay, so we used our random number table to determine whether each one was going to be right or not right. And so now I'm going to go to the next page. I'm going to kind of combine my answers here. So let's see here. First, I'm going to count I'll count the threes up because that's easy. 1, 2. 2 threes. I'll put 2 X's there. For the twos, I've got 1, 2, 3, 4, 5, 5 twos. For the ones, I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I have 12 ones. And then for the zeros, I have 1, 2, 3, 4, 5, 6. I have 6. So it was 6 of those, it was 12 of those, it was 5 of those, and it was 2 of those. Okay? So what is the experimental probability of guessing 0 questions correctly? When I did it, it was 6 out of 25, which is the same as 24 hundredths, which is the same as 24%. One question correctly, 12 out of 25, which is the same as 48 hundredths, which is the same as 48%. 2 questions correctly was 5 out of 25, which would have been 20 hundredths or 20%. 3 questions correctly would have been 2 out of 25, which would have been 8 hundredths or 8%. 4 questions correctly would have been 0 out of 25, which is 0 or 0%. All 5 questions correctly, 0 out of 25, which would have been 0, which would have been 0%. Okay. To answer number 5, I need to go and look back. 1 second, please. All right, so if I take a look here, this was our last experiment where we just had 4 options, where it was just a 4 choice, multiple choice test, and we did the spinner, the online spinner as our simulation. Okay, and so we had 20% for 0 correct, we had 42% for 1 correct, we had 28% for 2 correct, we had 8% for 3 correct. Let me kind of line those up here. And so on this first one here, I'm trying to zoom out here, see if that helps. Maybe. All right. So if I look, 0 questions correctly for my 5 choice was 24%. For my 4 choice, experimental probability was 20%. Okay. For 1 correct, it was 48% for my 5 question test. So 5 choices here. A, B, C, D, and E. And then here is my 4 choices, kind of like the warm-up from yesterday. 4 choices, so it's A, B, C, D. Okay. Then 2 questions correctly was 28%. And then for 3 questions correctly, it was 8%. And the other 4 and 5 were also 0% for both days. Okay. So if I needed to explain this, if I was explaining this, how do the results compare? Well, it looks like when it was 5 choices, there's a higher chance, higher experimental probability of getting 0 correct, higher. There is a higher probability of getting 0 or 1 correct. Let's add those together real quick. There was a 72% chance of getting 0 or 1 questions correctly with 5 choices. There was a 62% chance of getting 0 or 1 correctly with 4 choices. Okay, so it's more likely now that I'm going to get 0 or 1 question correct. Okay, for 4 choices, it's a little bit higher to get 2 questions correct. And with 3 questions, it was the same in our experimental probability, just like it was the same for 4 or 5. I bet if we went and tried to do 6 choices, that our numbers would get closer to 0 and 1, as opposed to being, and then less for being 3 and less for being 2 as we increase the number of choices. Okay, so how do the results from this experiment with 5 answer choices for each question compare to the results from the experiment with 4 answer choices for each question? There was a higher percentage of trials that would get 0 or 1 answer correct than on the 4 choice multiple choice test than the 5 choice. I'm sorry, that happens. Then the 5 choice multiple question test. Okay. So as there's more choices on a multiple question test, the probability of guessing correctly seems to be getting much, much worse. All right. So we were doing simulations with a virtual coin. We were doing simulations with a virtual spinner. And this last time we were using a random number table to help simulate different types of situations, to look at the experimental probability, to think about the theoretical probability of a different situation. Okay, thank you.